So this presentation is going to be on hypothesis testing. And by the end of it, you will be able to understand what hypothesis testing is, what are the steps that we take if we want to carry out hypothesis test, and also the differences between a null hypothesis and also an alternative hypothesis. So a hypothesis is a statement or a proposition that scientific inquiries or scientific research can test. So for example, we can say that a drug X has the ability to reduce the risk of occurrence of a disease Y. Okay, so we can test whether indeed that drug X has an impact on the occurrence of a disease Y. So what we usually do in real practice is we carry out a study that involves us getting a sample from the larger population. So basically, we don't test whether the drug X has an impact on Y on everyone within a given population. We basically pick a few members of the population who we call the sample, and then we carry out the experiment, and then we can now make a conclusion or infer that indeed the drug has an impact on the disease Y. So usually there is something that we test for, or there is a variable that we test for. So there is there is always an unknown value for a given variable that we usually don't know about a population, but we basically get a hint on what that unknown population variable, which is actually called a parameter. We make a conclusion whether our sample actually provides us with something that is actually close to that population parameter. So that is the link between the population and then the sample. Okay, so what we get, the interest is that we determine that variable in a sample, and that is what we call a statistic, to be able to make conclusions about the population parameter. That distinction is very clear in us understanding hypothesis. So when we now carry out a hypothesis testing, we basically have a statement that we want to prove. So instead of proving this statement in everyone within a given population, we prove this statement by taking a measurement or taking the measure by measuring that variable in a sample. Okay, so if you are going to say that drug X has an impact on Y, we don't go and measure it on everything. We pick samples and then we determine. So we basically are testing the likelihood that what what we are seeing in the sample actually is a reflection of what the population parameter is all about. Okay, so basically, we make statements that we can test through our samples, and then now conclude about the population based on what we get from the samples. Okay, so we are testing whether a given claim is actually true or false based on what we get from a sample. So why do we do this? Why is it very, very important? It's very important, especially in research, because in research, we want to investigate a number of things. We want to know whether a drug X is better than drug Y. We want to know whether it is okay to invest in a new public health intervention compared to the other. We want to see if a given risk factor is actually associated with another disease. We want to know if you're exposed to a given pollutant, it increases the occurrence of a disease Y. So basically, we want to relate these things, and if we understand the relations between exposures and health outcomes, understanding risk factors and health outcomes, understanding the impact of interventions on population health outcomes, then it means that we can be able to actually make decisions on what we ought to do based on evidence. So how do you carry out this hypothesis testing? So you need to first state the hypothesis, and then set the criteria for which you can make a decision, and then, of course, you choose a statistical test, and then interpret that statistical test, and then make a decision. So let's look at the details, really. So stating the hypothesis, what you need to realize that we have two types of hypothesis. Okay. The first one is what you call the null hypothesis, which is basically stating that, you see, whether you use drug Y and X, it does not really contribute to anything. There is nothing that the two will have on health. So there is no difference between using drug X or Y. So when you state that, it means that you're stating a null hypothesis. So you're basically stating that there is no significant difference between two groups or two variables. Okay, so in our example of a new drug X and the risk for occurrence of disease Y, you're basically going to say that the new drug X does not significantly affect the risk of having a disease Y. That is a null hypothesis. The other type of a hypothesis is what you call the alternative hypothesis, which is basically that there is actually a significant difference between the two variables. In this case, you're saying that actually the new drug X significantly affects the occurrence of disease Y. So for it is actually the opposite of the null hypothesis. So you need to first state the the two hypotheses and then be able to accept one and reject the other. So before you can actually accept or reject, you need to set the level of significance. You need to make a decision on the level of significance. Usually, we use the level of significance as 0.05. This is very important. It's a constant and it's what is usually conventionally used. So the alpha basically is you making a decision on about your willingness to accept that you can make what we call a type 1 error. Okay? A type 1 error is maybe let's first look at those errors before we proceed. So a type 1 error is when you reject a true null hypothesis. So the null hypothesis basically saying that there is no significant difference between two variables. Okay? And then for you carry out your study, and then you reject it. You reject the null hypothesis, which is actually correct. In reality, it is correct, but for you rejecting it. That is what we call a type 1 error. So the probability of rejecting a true null hypothesis is what you call a type 1 error. Now, the type 2 error is for you to accept the null hypothesis as true, yet it is actually false. Okay, so you're basically saying that the drug X does not have an impact on the risk of having a disease Y. Okay, and then you agree with it, yet it is actually false. So accepting a null hypothesis when it is actually false is a type 2 error. So you need to make a judgment. You need to make a judgment on what level are you going to accept that you are willing to make what we call a type 1 error. So you can accept it at 0.05. This is to say that you're accepting that you're making a type 1 error at 5%. Okay, but 95% of that means that you're not willing to accept that you're making a type 1 error. So you choose a statistical test and then make an interpretation in relation to the null hypothesis. So we have different types of statistical tests: the chi-square, the t-test, and others that we shall look at in our subsequent lectures. So since we have very many statistical tests, it is very important you know which one to use. The decision to choose which one depends on many factors. One, the objectives of the study, the hypothesis, the type of the data that you have, and the health outcome that you're actually investigating, and the nature of its distribution. So you need to look at your data set very well and be able to make a decision. But of course, making a decision that does not necessarily rely entirely on the statistical test. There are other factors that you really need to look at, such that you can arrive at the right decision. So in this presentation, you have basically noted that you can perform hypothesis and testing to identify whether the null hypothesis is actually true or false, and we have looked at all the different steps that you can take. Our next presentations will be on the different statistical tests that you can carry out to prove whether the null hypothesis can be accepted or rejected. Thank you very much.